This chapter is called Dynamic Memory. I would suggest, before starting this chapter, that you make sure that you understand everything that we've spoken so far about pointers. Dynamic memory is very, very heavily reliant upon your knowledge of pointers. So if you don't get it with pointers, I suggest that you go back and review it. So anyway, let's actually talk about what dynamic memory is. Now, recall from our earlier discussion on scope that there are two lifetimes that a variable can have. The first variables that have a lifetime of the entire duration of the program. And the other, of course, is block variables or stack variables or local variables that have the lifetime of the block they are contained within. With what we know about C so far, those are the only two lifetimes that we as a programmer can take advantage of. But by using dynamic memory constructs, we can actually have a third way of obtaining memory. The lifetime of dynamic memory is that it is created when we need it, and it is destroyed when we are finished with it, and we decide when it's created and when it's destroyed. When we wish to have a piece of memory created, then we simply make a request to the operating system. We say, I need 300,000 bytes of memory, or however much I need. The operating system then checks to see if that amount of memory is available, and it gives it to me. And then I continue using it until I decide that I'm finished with it, at which point I let the operating system know that I no longer wish to use it anymore. Once I've done that, I can no longer use that little piece of memory anymore. So I guess to summarize, you would say that the lifetime of that memory is defined by us, by the programmer. It's much more flexible in that regard. We call this memory dynamic memory, and we also occasionally know it as heap memory. We'll learn more about those terms in just a moment. Now, unlike global variables and local variables, you don't actually declare variables that are dynamic memory variables. You don't declare them. You don't say, all right, I'd like an array of structures of type employee, I'd like 300 of them, go. And you don't declare that as you would declare a local variable or a global variable. Instead, what you do is you request the chunk of memory from the operating system. You actually have to work out yourself how big that memory should be. So if your employee structure is 1,000 bytes and you need 300 of them, that's when you would ask for 300,000 bytes. And then the operating system will actually give you back a memory address that represents the start of the memory that you asked for. You then assign that to a pointer variable that you happen to have lying around. So your pointer variable then forevermore points to that particular area of memory that you got from the operating system. And thus, of course, you can then use it. You can dereference the pointer and access the information inside it. You can treat that memory by the appropriate use of casting. You can treat it as anything you like. You can treat it as a structure or an array, some ints, a float, whatever you like. And of course I will show you how to do that in this chapter. Now before we go and actually have a look at some coding examples for dynamic memory, I think it's actually important that we have a look at how memory is represented in any running program.